Six. One. So what you guys got? And then divided by 4.8. And so this whole concentration, the whole thing molarity should be 0.292 molar. Yeah. Yeah. What you're going to then do is you're going to fill up one of those cuvettes. Remember those cuvettes? Put it into the calorimeter and record percent transmittance and absorbance. Oh, I'm sorry. Thank you for letting me know. And that's what's going to check. So this will be pink. Remember the little calorimeter next to the computer? Put that in there and record your transmittance and absorbance. And what you think the molarity is. What do you think? Yes, sir.
I noticed. I actually did it 2 ways. I thought that if you want to take the proportion of the milliliters, so in other words, the amount of it compared to the total, multiply that by the specific molarity, and then all of them up, you get roughly the same amount. So I think that you could do that too. Although interestingly enough, my answer was off a little bit by the calculation that we all did. So.
Yeah, this is really incredibly simple calculations here. Not going to hold up when you get to a little more real life examples. Yeah. What do you think, though? You guys feel comfortable doing that? And I'm going to have you use the pipettes just for practice. Yes.
For the calorimeter, like where will that be connected to?
A laptop.
Anyone's or just
Oh, I'll just grab 2 from the library. Yeah, teachers are allowed to have more than one. So it won't be your laptop. It'll all be set up and everything. You're literally just going to stick it in there. And then wash it out. Sound good? Okay, so then we have one more topic. One more topic and we're done with this unit. Oh my gosh, we only have 2 more units left after this. I kind of don't want to end this one. The year's going to be over before we know it. Okay, so the last topic isn't really new, but I just want to reiterate that remember water auto ionizes into the hydronium ion and the hydroxide ion. And we look at this as the acid, we look at this as the base. Since it's at equilibrium, this is the Ka, and this is the Kb. So this is Kw. Kw is the dissociation constant of water. And We already know the dissociation constant of water. It was in your notes, but just to remind you, it's 1 times 10 to the minus 14. And this has no units. This has no units because they've already canceled out. Remember, our Ks are the concentration of the products over the concentration of the reactants. And if both of these are molarity, molarity over molarity, they cancel out, right? So there's no units to K values. No units to K values. But Kw is equal to Ka times Kb. So this is always going to be equal to Ka times Kb. So we want to see that in action, don't we? Yes, sir.
Is Ka and Kb just the pH or the pOH of them?
Not the pH or the pOH. It can be, you remember, okay, great question. So remember, pH is the negative log of the hydrogen ion concentration. So that means 10 to the negative pH gives you the hydrogen ion concentration. So if given pH, you may or may not be able to find Ka or Kb depending on, remember H2, oh, I'm sorry, H3PO4. When this dissociates, there are 3 H pluses for every 1 PO4 3 minus, right? So it's not straight up. You might have to multiply this by a factor depending on the dissociation molar coefficients. But other than that, yes. So it's not straight up that. It could be a multiple of the pH or POH. So in your workbook on page 206, let's check it out. I think that's the last page we got. Can you calculate the Kb if you're given the Ka? And here we're trying to find the conjugate base of phosphoric acid, the Kb of the conjugate base, given Ka. Can you guys do that? What did I just, remember Kw equals Ka times Kb. So what are you going to do? Anyone? Anyone? Bueller? Bueller? Yes.
Divide the 1 times 10 to the negative 15 by 10.
Yep, you're going to do Kw divided by Ka equal Kb. Yep. So 1 times 10 to the minus 14 divided by 7.5 times 10 to the minus 3, and you get that's the K of Kw, the dissociation of water.
Water?
Water.
That's not. Why are you using it for phosphoric acid?
Okay, this will only dissociate in water,
Oh,
right? So when they dissociate in water, yeah.
Yeah.
So here we go. the auto ionization of water. Pure water happens 1 out of each one of these times for the water molecule. That's where you get the Kw. And that's just the inherent property of water. Remember the scale, we didn't make this up. This is just an inherent property of water. So, and if we have a whole bunch of hydrogen ions, then we don't have hydroxide ions. So it's this relationship. And they have to, when we say it has to equal 14, so this is just kind of like a more grown-up way of saying it has to equal 14. This guy. Yeah. Cool. The next one, we're looking for the acid dissociation constant. So that's the Ka, looking for Ka. We're given the 0.1 molar HCO3. So this is acetic acid or vinegar, and it gives us the hydrogen ion concentration. So it gives us the hydrogen ion concentration for this. So if we think about, where is this? We think about HCH3COO. At equilibrium, it's going to dissociate into hydrogen ions in our acetate ion. Not that you have to write this down. We know that this is 0.1 molar. That's what this guy starts out with. So we know the concentration here. And then this is telling us the concentration here. So if they tell us the concentration is 1.32 times 10 to the minus 3 for this, and we look at the formula, if that's this concentration, that's also the acetate ions concentration, right? Because when that breaks apart, you get one of those and one of those. When you split this in half, if you have one of those, you're going to have one of those. So however many of these you have the same of these, 1.32 times 10 to the minus 3. Now, if we remember how to write this, it's products. So the Ka is the concentration of the hydrogen ion and the anion. So that's the 1.32 times 10 to the minus 3. Times 1.32 times 10 to the minus 3. And in your calculator, you could just do it squared. Remember, it's divided by this guy, the concentration where it starts. And the whole idea is acetic acid is not a strong acid. 100% of this is not going to dissociate because it's not a strong acid. So you'll divide by that. And since these are molar, the molar cancels. So what do you get? In your calculator, do this times this, hit equals, divided by this. Not going to do it.
Times 10 to the minus 1.
Yeah, K is 1.74 times 10 to the minus 5. Perfect. Perfect, perfect, perfect. Now the next question is identical to this question. Identical to this question, because when it dissociates, you're going to have one of these and one of these. The only difference is instead of giving you the hydrogen ion concentration, they give you the pH. And you can just do 10 to the negative 4.23, and that will give you the hydrogen ion concentration. And again, if we look at the dissociation, a hydrogen chlorate dissociates into the hydrogen ion and one chlorite ion. So when we do this, what do we get? pH. What do we get? What do you get? What do you get? What do you get? Anyone? Anyone? Check in the chat. Anyone? Can you do 10 to the minus 4.23? Anyone?
8, 9, 10,
It's 10 to the minus 5, and that is for the hydrogen ion concentration. And that would be the same for the chloride ion. Right. And then what are we going to divide it by? Yep. This is the molarity of the whole thing. That's the concentration of the reactants before it breaks apart. So 0.1 there, 0. And that will give us our Ka. It was just another way of giving us the concentration of hydrogen ion by giving us the pH. I got 3.47, but I could be wrong. Yes.
Putting it out into the 5.9 times 10 to the negative fifth, can you just do 10 to the negative 4.3 or 23 squared over 0.1?
Yeah, of course. Oh, oh, before the end of class. Okay. Yep. Yes, you could. I was just trying to make it consistent with this one to show where that came from. Yeah, he just put this in squared. Divided by 0.1. In your calculator. That works too, but trying to keep it with the Ka format. What do you think? Want to do another one? No? Okay, cool. So in your workbooks, let's highlight. Page 189, circle page 189. So out of the 12 questions, only 5 of them require a calculator. So there's only 5 calculation problems. You will have to solve, molarity is mole over liter, right? So you have one question where you're looking for concentration, one question where you have to solve for moles, and one question where you have to solve for volume. So from this page, you can do that. You're good for 3 of them, 3 out of the 5. If you look at page 198, 98, you will have to write net ionic equations for Bronston-Lowry acid. 199, you'll have to do net ionic equations for Bronston-Lowry base. And you have to find the conjugate acid and conjugate base of whatever I give you, conjugate acid, conjugate base. So 198, 199. That's not really a calculation problem. I didn't count those as calculation. It's just where you put in the hydrogens. So you want to represent acid, base, and conjugate acid and conjugate base. And then on page 203, pH problems would be like these. These problems will be like that. Your Ka problem will come from page 206. So if you can do these guys, you'll be golden. Well, pretty much these guys, you'll be golden. Yeah, because these guys are the same. So we just did, we'll take care of 206 and 209. You'll have a titration problem. Kind of take the stress off and make sure your test comes from the workbook. Yes, sir.
What is that for the 1,089?
189. Let me see for 189. Oh, see how this one says calculate the volume and it gives you molarity in grams. And this one's calculate the concentration. And this one's calculate the mass, which is like moles. So you'll have to calculate the concentration, the mole for the volume. So you have to be able to solve for each one of those depending on what the question asks you. What do we think? Yes, sir.
I have a question. On this test, would you anticipate that people will miss the most?
When you have to correct the label on the lab, because you guys really bombed the label. That's what I think you're gonna miss the most. The math isn't hard, the algebra is not hard. There's no diatomics in there. You're not really translating from formulas, pretty much have molar mass. So yeah, I think the labels are gonna throw you for a loop. And reading the burette in lab. Because you guys kind of didn't do well on that either. But I could be wrong. I no. I'm wrong all the time about you guys. What do you think you're gonna miss the most? What do you think you're gonna miss?
Honestly, I think I'm just going to miss the KA and KB stuff. I'm not too familiar on that right now. Just my fact, so I mean, who knows?
Yep, well, to do well, you when K, the KA and KB, this is what you need to remember. So if you're given one of these with knowing KW, you can find the other one. Right? So memorize the KW is 1 times 10 to the minus 14. That 14 should be a little familiar because the scale, the pH scale goes from 0 to 14. Remember, pH and pOH have to equal 14. So 14 is not completely a random number. So yeah, it's kind of like memorizing that formula. Anyone else have a topic they think they're not going to do well on? Yes.
Well, this is a question kind of related to it, but where is the playlist with all the videos?
Where is the playlist? That is on one of the previous days. Hold on. Let me get to. What day was that? Oh. Don't fall behind. Is it day 5 maybe? I can post it again if I don't find it. 6. Huh. I will post it again, sweetie. Shouldn't be this hard to find, my bad. Sorry about that. Yes, sir.
I wonder if there's gonna be a question on the buffers, like.
Nope. No buffers. You need to be able to define a Lewis acid and base, an Arrhenius acid and base, and a Bronston-Lowry acid and base. So that's from your reading. Yeah, so calculate the volume if you're given molarity and grams. This is molarity by dilution, so this is M1V1 equals M2V2. How did Arrhenius describe acids and bases? How did Bronston-Lowry describe acids and bases? How does Lewis describe acids and bases? Net ionic for Bronston-Lowry acid. Show net ionic for Bronston-Lowry base. What's the conjugate acid and the conjugate base for each of the following? What's the pH and pOH? Yeah, this many grams of acetic acid into the volume is this. So you just calculate molarity first, and then the pH is negative log of the molarity. So calculate the KB, but you're given the Ka. And then here's a titration. It tells you how much you've titrated. So that's an M1, V1, M2, V2, which is going to have the lowest boiling point from all the solutions on the test. So if you're looking for lowest boiling point, what are you looking for molarity wise? The smallest molarity, right? Smallest molarity will have the lowest boiling point. And then it's three lab questions, stations that will, one of which you already know. One of which will be the putting a bunch of different Kool-Aids together, figuring out the molarity, and then testing it with the calorimeter. Yes. What? Yes. But you'll only be doing 3. So you'll either be doing this side or you'll do the back 3. So you have enough time. Sound good? Okay, so you have the rest of class to work on whatever you want unless anyone has questions. Nope, and I will get that playlist posted again. All right, now. I go into here. YouTube. Go into my channel. Solutions, playlist. Oh, I'm sorry. Do you need this?
I have some questions.
Can I just want to repost the playlist. Here. Okay.
Someone put like so someone did it and someone put on the one of the community in front of it. Have a Jolly Rancher.
Yes, you may.
Thank you.
Okay, yes, what can I help you? Thank you. Play this. Okay. Yes.
For, you wanted us to say the equation in our video, do you want us to include water in the equation, or do you want us to include this?
Just that.
Okay, and then, do you want us to include calculations for one, two, and
No, they were just practice, just what you did.
Okay, and then also, is it okay if only one of us mirrors the video, just because we're trying to split the work evenly, if we didn't mirror, like, the time lapse, so I was gonna do that.
If that's how you want to split it evenly, thanks for letting me know, because sometimes when only one person narrates, I kind of assume that,
Yeah.
yeah, I get
Thank
that.
you.
This should go with me. Because there's like, we both did some part of the,
Is that hard for someone to say something up front or to say something at the end?
okay. I have two questions on the workbook. Well, for, that's a, on this page, I know how to do this, or, I know it's like, yeah.
Right, that's all it is, and 6 water leaks. So you add the mass of everything together, like you're doing for the copper chloride, dihydrate. The copper chloride and 2 water all together. So it's, yeah, it's all associated with, but basically you're gonna split a molar mass.
I don't know if
the equations for acting as an action.
So when it, what that means is, see how all these are H's,
Yeah.
right? So basically, to act as an acid, the bronze iron is donating a proton.
Yeah.
So it's giving up a proton. So this guy is going to give up a proton. And when it gives up a proton, this is left, and it's an ion. It's negative charge because the proton is positive charge.
So I do.
Yeah.
Oh, okay.
Yeah, instead of having 2 hydrogens, and that has 1. And when this gives up, yep, that's what it is.
Okay.
2 minus of those 8.
Okay, thank you.
So, put your phone down right here.
what are we supposed to add?
What does it say in the rubric? What rubric?
I didn't know that it had the directions book, like I was just reading the directions like it's
Okay. Clear recording of complete reaction in focus, appropriate length, lab members' first and last name, periods included at the beginning of the video. Okay, so like, if you took a video, you should crop out. I just want to see the reaction.
So my dad's.
So crop out the other stuff.
And it, do you want it like a time lapse type thing?
Where's ice?
Pretty much, yeah. I'm only gonna watch like a couple of minute videos. If you didn't do a timer, I'm gonna sit for an hour and watch a video.
Yeah, I was just gonna like put it in an edit.
Yeah, exactly. Verbal narration, appropriate volume, and at needed time. So you're just gonna explain what's going on. Correct explanation of what's occurring. If you tell me that the aluminum's being eaten up by the copper acid, that would not be good. So whatever you say, it says correct explanation of what's occurring. Reference to the type of reaction. So somewhere in there, you should say this is a single replacement reaction. And then a clear visual of an explanation of your stoichiometry calculation. So some people are like, oh, should we take pictures of your work? You could just add text in your video telling me what amount of aluminum you should have gotten and what amount you got.
And then like,
Or it could even be pictures of the balance, and you just say, according to stoichiometry, I should have gotten this, but I actually got.
And then if we both like work together on like the narration and stuff, like we just turn the same video.
Yeah, I'm not getting 150 of them. I should only get 75 of them.
So only one.
Yeah. And it doesn't matter which one, because both your names are at the beginning of the recording.
Like if you just scroll through it, if I were to.
What's the best way to mask your remember if I had a bunch of
Gotcha, that was not what I was
Shake
thinking
that
about.
copper off.
We probably want-
And then you masked it before,
Yes, I'm saying
so
that.
shake the copper off and mask, let it dry, or shake the water off too, and then mask it again.
Yeah, I was gonna ask.
So I forgot to do a time lapse and I just did a regular video. So it's like,
So there's some video editors that'll let you speed it up.
but it's too big to export into any video editor.
Then is there an app you could download? that
I
you
tried to
can-
do it with iMovie and it's still, I did it with
Parking
this
lot
morning. and it's still
Don't worry about it.
By that, I mean, driving around at less than 10 miles an hour, learning how to turn a car. Which took longer than it should. Yeah, no,
Ask the guy in the library, the guy in the back of the library, his name is Ryan Richardson. He's the tech guru for students,
Okay.
so you can go there now
Do
and
I need
ask
a
him.
pass?
Yeah.
I have like a 90 accessory.
Yeah,
See,
see
the other
what he
10
can
I
do.
don't want to talk about. One time, like the second time, I remember, I was going into a,
No.
Safeway parking lot.
You know where he is, the office in the back of the library.
And,
The poster on We
yeah,
Video.
so the two parking
Like I
spots, like,
said,
this is the parking spot
Are we
here.
not using
this is the one,
Right.
I park here.
Right, because you can use it as your editor.
Yes, but to turn it in.
Yeah, we're not doing that because it didn't open up Classroom for you guys.
Yeah.
So you'll just put it in the other two locations.
Yes.
The anti-library.
Come here.
Schoology and.
They said, hey,
Oh,
we're gonna go to the parking lot.
So in
Do a,
Schoology,
2 hours
there's this
Oh,
and
there's-
this.
and then that.
Send it 50
Which
miles
I
per
don't
hour.
remember what it's called, but it's supposed to be like this place where
Not, oh well.
you have your account. What you want to do is you want to go to, for you, see how mine says courses. You're going to go to, ooh, look, oh, shoot. Someone's already turned it in, but it should be, you're going to go to your group,
Okay. Yeah.
7th period count.
I gotta try it. I gotta let it.
So let's see what this looks like.
We experimented with a copper 2 chloride solution of a 0.1 concentration. This reaction was a simple replacement with aluminum and copper chloride reacting to yield copper and aluminum chloride. From our calculations, 0.027 grams of aluminum was the theoretical amount of aluminum that should be consumed. During the experiment, a small amount of the copper 2 chloride dihydrate solution spilled. However, the experiment consumed twice as much aluminum than predicted. The initial mass of aluminum was 0.75 grams and the final mass was 0.60 grams. Therefore, 0.06 grams of aluminum was consumed, which is double the amount predicted, which is 0.03 grams of aluminum.
I got it. I got one of them. I've done this. My brother.
Who on earth are they?
Stuff.
Who on earth are they?
They had another game.
Ah,
We experimented with a copper 2 chloride solution.
well, that
of a
wasn't
0.1
fast enough. That
concentration.
was too fast. What period? Oh, period 1, sorry. So that was 43 seconds. That was a 43-second video, totally adequate. Can I move that?
Would you like to see the other parts of the experiment? Videos of like the mass and the whatever.
That'd be great.
Okay.
I mean, that's more work than you have to do, but that'd be great.
Okay.
Yeah, let me see if I can get this, somehow move it to the group. So yeah, this is some weird thing. So we'll see how this turns out
Okay.
for adding it.
All right, 2 locations.
2 locations, yes. Yeah.
Okay, so we waited like 3 hours for you, and like nothing happened to it.
Oh,
But the ones, the point, like, point 2 3 that we put in, it is clearly a lot different now. But
so this is the one you had put in before.
yeah,
And then you came in and added more.
because we thought that it needed that much more to completely.
The copper? Nope. Nope. Yeah,
Did I hear that right?
yep. So you need just a good picture of this to show. And so you really didn't have to add the more if it would have used this aluminum part. Your math must be right.
But I'm kind of confused, like, everyone else was adding 0.7 grams or something, but I thought we were.
Why do you even know what other people are doing?
I saw their wire.
Yeah. Well, I told them to have the wire to be at least as long so you can pull it out,
Oh,
right? So you're gonna have to get some chewing gum. And you're gonna have to chew the gum and you attach it to the bottom of a pencil. And then you gotta stick it in there to grab that. Get it out. And I'm not kidding.
I don't want to.
I do not have any spare gum. I'm not kidding. It's the only way. I worked with another student. It's the only way we got it out. We tried every tweezer, hemostat, everything we have. So, yeah, because you gotta get that out of there. Actually, you gotta get both pieces out of there and mass them.
okay.
You gotta get both pieces out there and mass them to find out what really was consumed. It's aluminum wire. Well, I
We
didn't.
could just like pour it into a whey boat or something. 'Cause we don't really need the copper.
Well, you're not gonna throw it out.
Yeah, we would. We should just put the copper back in.
Okay, maybe.
Would that be acceptable?
Yeah, give it a shot. Dry off your aluminum, weigh it again. Because basically you removed all the copper from solution.
Yeah.
So how much aluminum did you use to do that?
Okay,
That's
that would
what you
be-
want to find
that
out.
would be the math of it.
Uh-huh. Could be different. That's why it's important you get it dry so there's no water on it.
Okay.
Where's your aluminum?
Yeah.
Well, once you take it off the scale, put it back in there, and then when you're finished, like you're finished with it, then see all these tubes, these are all finished. So that rack up there, just find yourself a space. But with the aluminum, don't throw the aluminum out. The second blue drawer on the right says Weibo. Second one down, second one, no, down, from on the right. There.
Well, which means that. So we have to just like find the aluminum too.
And to see if it matches your stoichiometry.
I mean, I don't want it, I didn't like, I think it's. I no, literally, I literally made this morning, like, don't worry about it. It's just all my classes. Why do you have like?
Well, I always.
More so, we just catch the days like I Spanish was. So you know, like Spanish or Shrek was.
Re-experiment.
So. All my attention on the days I'm gone, already taking the stuff. It's like, we're also. We learned our last week on the test. So I want to take that. I like. Yeah, that's. You know how we're supposed to take. I'm already. That's why.
Yeah.
Who would you want more time? Not that I use that time, but. I have.
So I think
Yeah, we're you're not jumping out the solution that's wasteful, guys. We only got one planet. So just put it up here. Nothing's wrong with it, because it's dull, it's still aluminum. Guys, don't throw away your aluminum. When you're done, it comes right up here. Huh? Practice. 1, 2, 3, 4, 5, 6. No, this is the actual test.
Oh.
So it is 6 problems, one of which has 4 little tokens. 6. Students easily completed it in returns today. And returns next class with the whole period. So it's kind of like So 45 minutes. I mean, that's, I had 2 students easily take it.
We can't lose it, yeah.
Identify limiting reactant. How many grams of this to make this much? Okay. Given this many grams, but you're only this proficient, 83% yield. You can either divide by 0.83 first or wait to the end. Divide by 0.83. Theoretical says this, but experimentally you got this. So what's your percentage? It's the theoretical yield. You're given this and this. So that's like the limiting reactant problem. You gotta do both. And then whichever's lower is the theoretical yield. Because in theory, you can never make the one. You can run it. And then combustion of butane. And then it's a bunch of questions. How many moles can be burned? How many grams can be burned? How many moles of oxygen burned? How many grams of oxygen burned? So one mole. Good?
Chris Johnson. Can I plug in my phone so I can download the video?
Nope.
No. That's the original.
Yeah, that's what it said before class. Are you all packed up? Okay, yeah, because I don't know what they're gonna need you for testing. Sorry.
Should we explain like how we did our experiment? Or can we just like put our calculations and like time off?
So do you-
It worked.
Read the rubric. In the bin with all the aluminum.
Okay. So even if it's one week, I'll be.
Yes.
Okay.
Huh?
Here's the restroom, please.
Yes. You said something else. That-
Yeah, Connor had that.
Yes,
What was the name of the flask we used to make?
volumetric flask.
Volumetric flask. Okay, thank you.
That is a volumetric flask, 100 milliliter volumetric flask. Anyone staying after school today to retest?
Well, we're doing. Because you have to. Look at the rubric. Okay.
I figured.
No. I know.
You wrote the entire thing and then lost it.
No, I've got some results. You can't get around
It's the.
something.
Is it like
Oh, yeah. All of them.
Yeah, she's religion, like religion you follow, and then if any, and then there's a pleasure he wants her.
Oh, yeah.
Yeah. You're gonna take it. You're not.
Oh.
I really have that project I need to go work on.
What is the percentage? I got you one.
Oh, yeah, I forgot about that. What is that? I have looked at that too. It's basically, you're atheist.
Oh,
almost, just like-
Abby did go home.
So like, you don't.
Oh, I'm sorry, Stephen, I have just seen your message.
I tried to be sparing.
Remember, sorbents is equal to 2 minus the log of the percent
I was working.
transmittance.
see about the.
Yeah.
I will set the probe where to show both. Real issue. Trusting.
I think black
Clarity.
So right now, it would be man input, where I'm actually
Yes.
So how do I do this one?
It just means
Yeah, I'll do
Or,
it.
I don't original.
you do not multiply. You add them all. Add all. So you're gonna add copper. And you're gonna add 2 nitrogens, 6 oxygens, and 6 waters. All together to get the molar.
Oh, that's it. Oh, okay.
Yeah,
so
I
that
can
will-
make some pre-built categories.
No, that's the molar mass.
Right now, we have
And when you add all of this together, that's grams per mole. Right,
Oh, I see.
right. So calculate the mass required to make this.
I was just realizing.
Here's how many grams per in a mole, right? So,
But I can be up pretty fast.
but then it's, so you're gonna, yeah, so you're gonna do 0.2 molar equals 0.1 liters, multiply these together, you get what, 0.02 mole. So you'll take this times whatever you get.
Oh,
Right, because you're not gonna have a whole mole of it. You're only gonna put 0.02 moles of it. So this would be a big number of grams. So you're not gonna need all of those grams. For 1 whole mole, you only need less than those grams. You only need this much.
So Daniel, we get involved.
This times this equals that.
oh. So,
Solve for moles, and then it's saying calculate the mass. So you don't need a whole, remember, this is 1 mole. You don't need a whole mole of that, you only need this much.
You put a lot of complicated
oh,
topics
this
on
is-
there.
this
I'm
is-
just sorry, like when I went in there, I was.
Sorry, I don't know how long you were waiting for that. My bad. And I actually forgot entirely about it. How you feeling?
Like I went through this and I knew Trump or half of them. There's great arguments for both sides. I did a good job. I did a good part of saying. I did a very good job of making slides. I mean, maybe I should make that. I mean, you heard me. Oh, no.